Hi, everyone. I would like to present today a joint work with Sylvie about the intelligibility issue in explainable AI. So for sure, everyone here knows that explaining is a hard task. There are many reasons for that. Of course, the choice of the explanation model first, but also the size or structure of explanations, the computational complexity of deriving explanations, and beyond that, the intelligibility issue. The intelligibility issue just means that an explanation can be already computed, can be, in fact, short, can have a simple structure, but it can be still useless because it is not understandable by, say, the user. Okay, as Tim Miller recalled this in his invited lecture yesterday, you must have in mind that explanation is a social process involving at least two agents, human agents or artificial agents, actually, an explanation provider or explainer, but also an explanation receiver or explainee. Okay, so intelligibility is not just an intrinsic property of explanation. Okay, you have to, in order to make explanations intelligible, you have also to take into account the explainee, okay, the explanation receiver. So you have to consider a kind of user model, in some sense, associated with the explainee. So in this work and in this talk, I would like to show how to go from explanations to intelligible explanations, at least to show an approach to handle this issue. And I would like also to show how KR has developed some concepts and also some tools that can be useful to deal with such situations. Okay? So let me start with quite a basic scenario, an example, in order to make the intelligibility question more concrete. Okay, so let's go with Abraham at the ophthalmologist. Okay, Abraham is the explainee, and of course, the ophthalmologist will be the explainer. Okay, so the scenario is as follows. Abraham goes to an ophthalmologist because he has some eye trouble. Okay, he has a blurred vision. Close objects appear normal for him, but distant objects are blurry. Okay, so Abraham has some explanation for that. He believes that he suffers from myopia, so that eyeglasses will be enough to treat the problem. Okay, but anyway, he goes to the doctor, and of course, he indicates to her physician that he had blurred vision. But the doctor actually suspects another disease. Okay, she suspects that Abraham suffers from what is known as Marfan syndrome. Okay, so I guess that just as Abraham, you don't know what Marfan syndrome is. Okay, it is the first time that Abraham hears this disease name. This term is totally meaningless for Abraham. Okay, of course, it is meaningful for the doctor, for the physician, but it is not meaningful for Abraham. Okay, so what can be done in such a case? What should be an intelligible explanation? There are some, of course, some questions that Abraham would like to know. Is it a severe disease? How to cure it? Is it hereditary or not? Okay, all those points are of interest for Abraham at that stage. Okay, let me now show how we can make it formal. Okay, just to cover the situation when, for instance, the physician is not a human being, but an AI system. Okay, we first have to make precise the explanation model at hand. And here, basically, it will be an abductive model. Okay, so we consider some domain theory. For simplicity here, I consider propositional formula. We're going to consider as well, as it is often the case in abduction, a subset of specific propositional symbols called assumptions used to denote disease in this case. A third set is a set of propositional formulae called the manifestations, the symptoms to be explained. For instance, the fact that Abraham has a blurred vision. And among those global set of manifestations, which are not necessarily all those that must be explained, we focus on a subset of it, okay, the manifestations for which Abraham would like some explanations, okay? Other manifestations can be just observations done by the physician. Okay, so the very basic abductive model now. So what is an abductive explanation in this case? It is simply a conjunction of variables from the set of assumptions, okay, such that this explanation, this conjunction of variables is consistent with the domain theory. And together with the domain theory, it entails every manifestation to be explained. Okay, it is quite a standard model for logic-based abduction. Here, since we do not consider just a set M star of manifestations to be explained, but possibly other manifestations or observations made by the physician, okay, we need a notion of coverage of an explanation. So the larger set of manifestations, okay, that are actually explained by the abductive explanations is referred to as a set of manifestations covered by the explanation. And as you surely know, typically there exist many abductive explanations. Often one prefer minimal explanations. Minimal explanations are the weakest ones from a logical point of view. Okay, so they are in some sense the most plausible ones where you do not have any information about, for instance, the probability of disease. And if you want to define on this ground preferred explanations, we often need that, especially to focus on a subset of explanations, because there can be exponentially many explanations, but all of them are not equally preferred, equally interesting. What we can do is to aggregate several preference criteria, and for instance, consider both minimality and coverage. Okay, for instance, we can prefer among all the abductive explanations explaining a maximal set of, with respect to subset inclusion, a maximal set of manifestations, we can prefer those explanations that are minimal explanations. Okay? So, considering Abraham's case, okay, this can be made formal by considering the following domain theory here. Okay, so here basically the first implication here just states that if we assume that Abraham suffers from Marfan syndrome, then this explains why he has blurred vision. This is a hereditary disease. Okay, and this also explains something else, another manifestation observed by the physician but not known by Abraham as such, something which is known as Steinberg sign. Okay, actually the fact that the thumb is both hypermobile and longer than usual, okay, as depicted here on the picture. Okay, and here this equivalence here, okay, just explain what is Steinberg sign. Okay, so we have this definition. the consequences over the set of observations of Marfan syndrome, and something similar for the other disease considered here, myopia. Myopia can also explain the blurred vision, but it is not a hereditary disease. Okay, so here is the formal model corresponding to the previous scenario. Now, it is quite easy to check. Okay, you can do it with me. That, for instance, we have two minimal explanations for the manifestation to be explained here. M star, the fact that Abraham has a blurred vision. We can find two minimal abductive explanations here. Marfan syndrome on the one hand and myopia on the other hand. And as you can check here as well, the set of manifestations covered by the two diseases are not the same ones, okay? The set of manifestation covered by Marfan syndrome consists of both blurred vision and Steiner sign, as I explained previously, while the set of manifestations covered by myopia is just blurred vision, okay? And so for this reason, the physician, because more manifestations are covered by Marfan syndrome, the physician is going to actually prefer this disease as an explanation of what she observed. Okay, so now the problem is that, of course, Marfan syndrome is totally useless for Abraham. Abraham does not know what it means. Okay, so if we want to go a step further, what we can do here is to consider a notion of projection. Okay, projection onto a vocabulary. So now, given the explanation computed, for instance, or found by the physician, we also consider a subset of propositional symbols, which is the user vocabulary. Actually, the user vocabulary as perceived by the physician, okay, consisting of some, common knowledge, facts, but also, of course, the observations reported by Abraham, the fact that he has a blurred vision. Okay, so what is this projection? This is quite simple. The projection of an explanation onto a vocabulary simply is, given, of course, a domain theory, simply is the set of all the logical consequences of the explanation completed by the domain theory, okay, and the consequences over the user vocabulary, okay, over the facts, over the variables, the atoms that the user can understand. Okay, of course, this is an infinite set in general. And what is very interesting to observe here and to note is the fact that this projection mechanism is not specific to the explanation model we have considered. Okay, it is not specific to abduction. Okay, as soon as you have a domain theory and an explanation, you can compute, and a user, of course, vocabulary, you can compute such a projection, whatever the way the explanation has been generated. Okay, so now let's pursue the discussion. Abraham would like to get the information he may understand about his disease. Okay, from the discussion she had with Abraham, the physician assumes that in the vocabulary of concepts that can be understood by Abraham, there are myopia, there are blurred vision, hereditary disease, and also concepts like hypermobility of the thumb and a long thumb, okay, because it's quite simple facts. So she can make an assumption about the user vocabulary, the vocabulary of facts that can be understood by Abraham, and then project the explanation onto this vocabulary, given her domain theory. Okay, so what she can get this way is this conjunction here, okay, blurred vision. It is not myopia, it is a hereditary disease, and it corresponds to the fact, it also explains why the thumb is hypermobile and longer than usual. Okay, and of course, what we can do before reporting this statement is to filter out the fact that Abraham knows, okay, or the fact that at least the physician may believe that Abraham knows, like blood vision, because Abraham, okay, went to the physician because of the blood vision. So actually, he already knows that. So at the end, okay, the explanations that are reported by the physician is that, okay, Abraham, you do not suffer from myopia. And unfortunately, Marfan disease is hereditary, unlike myopia. Okay, so maybe a few words about an interesting question, actually, a suggestion that has been written in one of the reviews of the paper. Was this consists of those questions? Why not projecting before explaining? Okay, what about replacing the domain theory by its projection onto the vocabulary before computing explanations? Or what we can do in the same, considering the same idea, would be simply to restrict the set of assumptions to those facts, those variables belonging to the user vocabulary. Actually, it would not lead to the same explanations. And I can show that on this example. It would not lead to the same set of explanation in general. And of course, it would not lead as a consequence to the same set of intelligible consequences. Okay, let me briefly show this. If you consider the previous domain theory and you project it onto the user vocabulary, what you will get is simply this implication, something equivalent to this implication. Okay, the fact that myopia, okay, explains in some sense the blood vision, and it is not a hereditary disease. Okay, so considering this projected theory, we would get only one possible abductive explanation, myopia, okay, that is not the same as the preferred explanation found by the physician. Okay, we would get the same explanation if the set of assumptions would have been reduced to the set of understandable assumptions, so to say. Okay, and the point, of course, is that this is not the same explanation. It does not cover the same manifestations. Okay, so it is less preferred, and it does not have the same consequences. Okay, because myopia, for myopia, you can conclude that the disease is not hereditary. Okay, while of course this is not the case for Marfan syndrome. Okay, there must be, okay, this conflict with the consequences that can be deduced, that have been deduced previously. Okay, now a few words about representing projections. As I mentioned, the projection is a set of all logical consequences. It is an infinite set in general. Of course, it is not very convenient from a computational point of view, but it is equivalent to a notion which is well-known, the notion of forgetting. Okay, if you want to get a representation of this projection, what you can do is simply to project, okay, the conjunction of the domain theory with the explanation onto the user vocabulary, or to state it differently, to forget everything else. Okay, I'm not going to enter into the details of forgetting, but it is quite well known for time reasons. What I would like to show now, to discuss a bit, is how to evaluate this operation. So we start with explanations and we go to intelligible consequences of those explanations. What is lost in this case? Of course, in the general case, we are going to lose some information. Okay, Marfan disease, for instance, because it does not belong to the user vocabulary, this piece of information will not be reported, okay, to the user. There is an information loss in the general case. We cannot avoid that. What is nevertheless interesting is that in some sense, considering this notion of projection will lead to furnish to the explainee all the intelligible explanation given a user vocabulary. Okay, simply because forgetting is defined as the most general consequence of a given formula that belongs to a vocabulary that could be expressed using a specific set of symbols. Okay, so basically, instead of, if you now suppose that the user has a knowledge base, of course, which is generated over U, a set of atoms she can understand, and that this knowledge base is, so to say, correct. It is a logical consequence of the domain theory, but it is incomplete in general. It is not equivalent to the domain theory, okay? If you just provide the user with the explanation we start with, given his domain theory, he will not be able to derive the whole set, okay? The whole projection, typically only a subset. But if instead you will give her all the projection, then using her own domain theory, she will be able to derive precisely what could be derived considering the full domain theory. Okay, this is not very difficult to prove. Now, another dimension to be considered is the explanation dimension, the explanation side. Of course, here you need to consider a specific explanation model, okay? If you want to determine whether considering intelligible consequences of explanations preserve or not the explainability power of explanations. And considering abductive explanation, of course, this is not the case, okay? It is quite simple to show that. If you consider the previous scenario and you replace the explanation Marfan syndrome by the corresponding, projection, and focus only, of course, on those variables that can be considered as assumptions. So disease, in this case, you will get the empty conjunction. Of course, it is consistent with the domain theory, but it does not explain anything. Especially, it does not explain the fact that Abraham suffers from a broad vision. Okay. Maybe if I have time.
Not too much.
Not too much. So
we
very
started a bit late, but
okay, so very
1 or 2 minutes.
Quickly, a few words about this is not in the paper, but in the extended version, and there's a link in the paper about that. It can be the case that the explanations are not intelligible, directly intelligible by the explainee, but an interesting situation is when those explanations can be reformulated in terms of the explainee vocabulary. And again, this actually amounts to a problem that is well known in logic for decades, the definability issue. Okay, definability is when you are able, given the domain theory, to find a formula equivalent, okay, to a given here explanation, but this formula this time is generated using only a specific vocabulary. Here, the user vocabulary. Okay, and for instance, to pursue with the Abraham case, Abraham at that stage may ask a doctor for a counterfactual or contrastive explanation. Why not considering myopia as an explanation? And in that case, the physician can just explain, okay, I have seen Steinmer's sign, and myopia does not explain Steinmer's sign. But of course, Steinmer's sign is just like Marfan syndrome. It cannot be understood by the user, but by Abraham. Okay, so it is not intelligible. But this time, it can be reformulated, It can be reformulated using Abraham's vocabulary. We have an equivalence. Okay, Steinberg's sign is precisely when the thumb is hypermobile and longer than usual. Okay? So if you consider that, this possibility of when you have an explanation that can be defined using the user vocabulary, of course, this is a specific case. In this situation, the explanation power for the abductive model is somewhat preserved. Okay, so the details are in the long version, extended version of the paper. Okay, so to conclude, basically what I wanted to show you here is going from explanation to intelligible ones requires to put in the picture a model of the explainee. Okay. In this work, we have considered a very simple model, just a logical vocabulary. We have used a notion of projection to characterize the consequences of an explanation that can be understood. And we have evaluated this projection operation in terms of information, intelligibility, explainability. We have also studied the case of definable explanations. And in the long version of the paper, we have also explained a bit how theory reasoning can be used to simplify the explanations that are reported. And just to conclude, to finish, the next steps. Of course, the next steps will be to consider more expressive settings than classical propositional logic and determine whether and to which extent the results shown here can be lifted, generalized. Considering, of course, also other explanation models. There is one in the paper about consistent explanations that, in some sense, generalize the abductive model. And a quite interesting operation, I think, is that what we use here are very basic operations, especially forgetting. And forgetting has been studied, analyzed in many logical settings, logic programming, modal logics, description logics, and so on. We have many papers, we have some pieces of software. So this could be interesting to lift the result here to those logical settings. And thanks a lot.